Alright, so we have a board that I don't really want to fix. I worked on this briefly the other day before giving up. The no sound. You have sound. The weird thing about this was on PP3v3S3 it had a short. I inject voltage and the short goes away. So I don't know what's up with this darn thing. I don't know what's going on. We're going to compare it to a different board too about the ohm reading we have on PP3v3S3 now. So we know we have a fault on this board somewhere, but we don't know what. It could be several things going on. This board is absolutely spotless, has no liquid damage, has no physical damage. It looks pristine, yet it does not work. So we have to figure out why it doesn't work. So let's go ahead and do that now. Let's go under the microscope first and have a look. Let's see who's in chat. Aaron is here. Paul is here. Hi, Paul. I haven't seen you in a long time here. Teresa is here. Adrian is here. Okay, so we had a short on PP3v3S3. Now we don't have a short on PP3v3S3, which makes it kind of hard because we don't know what's going on. So the main thing to think about on PP3v3S3 is camera. We have a lot of junk on camera. So this was the probe point I used to test. So let's go ahead and see what this is in ohms mode now. And in addition, I injected voltage. There was nothing standing out on thermal, so we have no clues to what is shorted or what may be shorted. So let's see what we get on PP3v3S5. I mean PP3v3S3, and we have 169 ohms. Now let's compare that to another board that doesn't work, but it doesn't have a short there. So let's compare that to another board. And we get oh well. Let's see. Resistance mode. Auto ranging. No, not diode mode I want. Four kilo ohms. So 260 ohms is not normal by any means for this rail. So now we have a real wonderful thing to find, because guess what? 160 ohms is not really going to get hot. So yeah, 268 ohms. It could be literally anything on this rail, and it could be this stupid camera I see here. So in a situation like this, it could be anything on here. So let's go ahead and look at what is on this rail. So PP3v3S3. Let's go ahead and open up a board view and schematic for this, and let's have a look and see what is on this rail. So this is an 820000165 used from 2015 to 2017 in the A1466 MacBook Pros. It is very similar to the 8203437 with regards that the 00165 has quad SPI and uses a Broadwell CPU compared to dual SPI and a Haswell CPU. So let's open the schematic here to PP3v3S3. Let me go over to my display capture here, which I believe should be right here. So PP3v3S3 is going to be right here. PP3v3 RSO camera is going to be the same thing. I believe it is anyway. You know what? For the heck of it, let's see. Okay, let's look at the schematic and let's see if it's on the camera side or let's figure out, and let's try and cut power to the camera circuit, and let's see if it's on the system side or the camera side if we can. So let's go ahead and open this up. Alright, we need to try, so this is just for camera current sense. I don't want this. I want to see supply voltage to camera. So in this case, so this software is great, but in this case I want my Adobe PDF. So I'm going to open Adobe PDF without showing any files that I'm not supposed to, like business related stuff. MacBook schematics 820000165. Right here. PP3v3_S3. And we can see this goes to a lot of stuff. That's 3v3S. Alright, yeah, this goes to a lot of stuff. Let's try and localize it. It goes into the CPU too. via 100 kilo ohm resistor. So a missing PM sleep S4L and a partial short. R1696. Would that cut voltage to my CPU? Okay, let's see if it's going, since we're right here, let's see if we take off this resistor. Let's see if it goes away from the CPU. I mean, let's see if we remove this, if the side is on the CPU side or the system side. Because if it's on the CPU side, then yeah. So R1696 over here. John, 269 ohms. It should be in the kilo ohms. R1696, I believe that was. So SSD power EN, right? Make sure. Yeah, exactly. Alright, so this is going to be the pull-up for SSD power EN. R6. Oh, shoot. This is on several things. Okay, screw that. That's on several things. Screw that. Hopefully not U3900. Exactly. My thoughts exactly. Alright, so I want to look at U3900 and I want to isolate PP3V3S3 from that if I can. It may not be possible, but let's see if I can. So let's go back to the schematic. U3900. And if we can cut power from it, then, you know what, screw your camera. Who wants camera? What the heck happened here? Adobe PDF, what happened? It used to be good. What is this? What is this? View, let's see. Alright, so U3900. Where's our input to this? We need our 3V3. Where's PP3V3? Let's find it here. One V35. I don't want that. Where is your input? This is the message that says this is allowed on YouTube. Where is, come on. Right here. Okay, this doesn't tell me anything. This is showing me a capacitor. And then to ground. Alright. Okay, so this is gonna suck. There is no... It goes direct to U3900. So there is no... Okay, so this is really, really gonna suck. So 269 ohms, nothing is really gonna get hot. Nothing's really going to get hot at that point. So my only thing left to do is to inject voltage and to watch it on thermal and see if there's anything that gets warm. Now, the thing of troubleshooting a short like this, it's not going to get hot instantly. It may get warm after like 10 or 15 minutes with voltage being injected. So I'm going to inject 3.3 volts. We don't want to exceed 3.3 volts. And I'm going to see if anything gets remotely warm or hot, but it's going to take a few minutes of watching on thermal to actually see if that's happening. So I'm going to solder a wire to the board and go from there. And this is not going to be fun, unfortunately, but we have one clue, and that is the issues on PP3V3S3. If the system sees a short or sees that something is pulling too much power on that rail, it's not going to let it turn on, so PM sleep S4L is not going to be asserted. It's going to, some power good signal somewhere is not going to work, and it's not going to be asserted that way. Hopefully it's a cap. I hope so too, John. I really hope so. So we're going to inject 3.3 volts. 3.30. The quicker I can fix boards tonight, I can go home. Friday, I'll have somebody else here to help, so it'll be nice. I like days when I have help. It is much better. I also wanted to see, also going to check that that's making it to PP3v3S3, because that's technically a rail for the camera. Right, we're pulling 0.135 amps. Nothing's going to get hot with that. It was shorted to begin with, and then when I first injected voltage, it wasn't. So let's see if that's making it to PP3v3S3. Sonia's here. Okay, U1880 is right here. We can check it on where's U2202? So U2202 is right across from that camera buffer. It's BGA, no stuff, and it's going to be on this pad right here. 1.30 amps, so it's dropping, which is not what we want. Okay, so interesting. That voltage is not making it to PP3v3S3, which is very interesting. What the heck did I inject it to? CPU is on that line, John. You know what? Okay, power supply's off. Let's see if PP3v3S3 has a short instead of PP3v3 camera or whatever. And 1.7 million ohms to ground. 234 ohms to ground. It's on the camera side. Okay, this is confusing. What the heck? PP3v3S3 milliohms, so it's not that. Okay, moving on. I don't think this is our issue. I think this is normal resistance right here. I do not think this is an issue. I could be wrong, but I do not think this is an issue right now. So no PM sleep S4L. Let's check our 32 kilohertz on the clock. Water. I feel dehydrated today. Alright, so oscilloscope's starting up. Let's plug the board in. Let's check our 32 kilohertz from the clock, and let's check if PP3v3 RTC is present. This area looks clean, so I really doubt this is an issue since I've never really seen one of these die like this, where clock fails on a board that looks like this. This is very, very depressing to me right now. PP3v3 RTC is going to show up right here. That's 3.34 volt, 3.314 volts, not that. Let's clip on our little alligator clip for the oscilloscope. And let's look at where our 32 kilohertz clock signal comes up. That is going to come up, where is it? Right here. And that is nice and present with a perfect sine wave at 32.7 kilohertz. It is not that. Let's check U1950 area. Which is not going to be that either because that looks perfectly fine. U1950 area is spotless. Why did I choose this board to work on? This is like really sad. Alright, PM PCH power okay is probably going to be missing, but that's irrelevant at this point. Yep, relevant, missing. So this circuit's completely irrelevant. Let's keep looking. PM sleep S4L can be caused by the littlest of junk on something that does not really matter. Well, you know what I mean. It could be pretty much anything. That doesn't look shorted, that looks more reworked by the factory or something. Nothing. Even this JTAG connector looks like spotless. Look at that poor JTAG connector. Looks perfect. Okay, so in this case where it looks perfectly spotless, what I want to do is check all rails for shorts. So anything, do you have all power rails? Why would we? We have PM sleep S4L missing. So in this case, since we already know we have our S5 voltage, we know we have our 32 kilohertz clock signal, we know we have our 3.3 volts from our clock chip. I want to go ahead and check all power rails, especially SO and S3 rails, for a short to ground. So I'm going to start with PP3V3SO and PP5VSO to see if there's a short there. So I'm going to do that now, and we're going to see if there's a short, because believe it or not, a short, and what? You know what, did my microscope freeze? Has my microscope been freezing all that time? I've been looking at this board the whole time and it froze. That's why people were leaving. Should have said something. 1 second. There we go. Okay, so I was looking at the whole board and it was completely frozen. Oh well. So I want to check for shorts since this board is flawless, you know. It's flawless. I'm sleepy. And I think Repair Shopper just took money out of an account that was closed. And Anel is here. Anel is here to screw up my night with dead CPUs, because it's always the CPU in Anel's case. It's always the CPU when Anel joins the chat, especially on a board that's missing PM sleep S4L. Always. PP5VSO, which is right over here. Let's check and see. And that is 29 kilo ohms to ground. _SO. Show up right over here. And that's 400 ohms to ground. 400 ohms to ground seems a little bit low. There's something here that is not right. I can tell you that right now. The 200 ohms and 400 ohms. So this should be in the kilo ohms. So here's my clue here. So there's a clue right here. So both PP3V3SO camera, or PP3V3S3 camera, and PP3V3SO are both low resistance to ground. They're not shorted, but they're both low resistance to ground. Now let's see, where does this go? So this, we're going to look around for some components, and we're going to see where both of these go and what they have in common. So I'm going to go over to my display capture. Display capture. So PP3V3SO is going to go to all these things. And this is connected to our camera rail, which is probably U3900. So R5421, which is showing up over here. Let's see. Let's remove this and let's see if that resistance goes up. And $367 ohms. It's the same. It's actually lower because it's hotter. So putting heat here, this is gonna suck. What am I doing using paint? Where do you see paint? I don't know where you see paint. Oh, that's why. You didn't see it under my microscope. So what I did is I took off resistor and it's still the same. So this is now confusing me. Because PP3V3SO is connected to the camera through this resistor right here. Alright, so still the same. I guess what I could do is go ahead and inject voltage in 3v3SO and see what amps it pulls and see if anything gets hot. Let's do that now. So I'm going to scrape away some of this so I can make a good solder joint. I don't want to rip that pad. So I want to make my own little pad that's copper directly onto the substrate. Remove CPU test resistance. Yes. Good thinking, Anel. Good thinking. Every darn stream you attend, the CPU always ends up being dead. Every single stream. You wait, you're gonna get what's coming. Next time you stream. Next time I visit. You're gonna have a whole bunch of dead CPUs. Okay. 1.32 amps. Nothing's gonna get hot at that rate. Gonna use my FLIR and look. Hey Tim, not looking too healthy. I look fine. No, so here's the thing. The camera angle changed, and for whatever reason, this camera is more clear than that one. So yeah, you just see what my face looks like. This is what my face looks like. Yeah, so injecting voltage is going to be useless in this. This is going to suck. So, who knows? I'm going to kick on my ultrasonic heat, and we're going to keep checking stuff while this gets hot. Screw that, putting that resistor back, it doesn't matter. This is going to suck. It kind of looks like someone's been probing here maybe once before me. How do you diagnose without any schematics? And now I am not 5'1" and 350 pounds. I'm taller than Anel. I'm way taller than Anel. How do you diagnose without any schematics? Who says I don't have schematics? Nobody said anything that I don't have schematics. So only thing I could think of, so PP3v3S3 is fine. PP3v3SO is not fine. We had a short on PP3v3S3 until I injected voltage the other day. And then now we don't have a short. As soon as I injected voltage, it went away. So there's either two things going on. There's a piece of silicon somewhere that's acting up, or there's corrosion in it or something, which is highly unlikely. Let's see. Stereo. You just have to, you get the hang of it eventually. It comes with time. Who votes I just start taking off stuff? Okay, I want to see something. Sometimes if you heat the back of the CPU a little bit and it turns on, it is a CPU issue. So I want to do that. I'm not heating enough to hurt it. I'm just heating enough to kind of flex the board. It's not hot enough to hurt it. I want to see, with it hot, if the board turns on. If the board turns on, then it's screwed. This will happen sometimes. And no fan spin, so it's not that. Another thing that can cause PM Sleep S4L missing is the BIOS. We could always try a different BIOS just for the heck of it. Since it is clean, that can theoretically cause failure. So what we can do is throw a new BIOS on. It doesn't have to be a clean ME region. We just want to see if it'll start. So let me dig out a 00165 board. And we could try a new BIOS on it. This is just to rule it out. If it does work, we'll have to clean the ME region. But if it doesn't work, then we'll put the old one back on. We do not want to lose that chip. So I'm going to put it up here where it's safe. Just grab the... Can we start calling CPU issues Anels? Yes. This board is an Anel. Let's let it cool a little bit. The board is too hot to turn on still. Anyone know here about Nintendo Switches? No, I have no clue about Nintendo Switches. No fan spin. Alright, let's put the old BIOS back. We ruled that out. About a year or two ago, I wrote a guide on how to troubleshoot PM Sleep S4L. Unfortunately, I don't remember much of which was in that guide, so I'm going to consult that guide. If I still have access to it, I think it might be gone. Because I don't remember stuff anymore like I used to. What the heck? Stay there. Alright, let's see if I still have my own guide that I forgot. I don't even have my own guide anymore. John, I need your help. Is John here? John, in the group, the old MacBook group, there should be a files portion that'll have that guide, because I don't have it anymore. I'm going to message you right now, too. My brain is too tired. Alright, so I know we need a few things. I can't believe I forgot my own guide. We have our clock signal, but should I just change the clock chip just for the heck of it? Sometimes it'll be fine. I know that's fine, but let's change it. Because a guess right now is as good as we're going to get. It's perfectly clean. John, send me my... Okay, thank you. I would remember this on a good day, but my mind right now is just too sleepy. This is why you write guides for yourself. So when you don't remember... New clock chip is soldered. Alright, so if this doesn't work, let's let the board cool. And we'll start checking signals. I will have fan spin. I don't think I will have fan spin. Let's see if we have fan spin. The board is still pretty hot. Should I turn it on or wait? Let's see, how hot is it really? It's only 145 degrees. That's cool enough for me. I'm exhausted, but I can't leave yet. I have to get stuff ready for tomorrow to ship out. Sad. Much sad. Okay, so let's start checking our rails or signals. First one is going to be PM sys reset L. It's probably going to be somewhere over here. Let's look it up. PM underscore sys reset L, and that'll be, I'll just check it. Let's see, there's a probe point near U7600, but it's going to show up near U7800, which is right here. There's a resistor here, right here, on R1995. So on R1995, with any luck, well, at this point it really doesn't tell us anything different. We know it's screwed. So it's kind of screwed. And that is 0.3 volts. Yeah. PM RSM reset L. Underscore RSM reset L. That'll show up over here. This chip looks completely clean. 0.01 volts. PM bat low L would cause it. She's going to go to the SMC, but also will show up on R4110. That's going to be hard to find, so I'm going to see if I can check that on Q3000. Q3000 is going to be somewhere over here, which is probably going to be non-accessible. Is that right here? Yes, non-accessible, so I will have to find it over here. And that will be on R1410. R1410. Looks like it's right here. Think. Just 3.35 volts, so we have that at least. But we're missing like everything else. This is screwed. SMC adapter EN is going to be present. Our SMC is fine. SMC underscore adapter EN, adapter enable. This has nothing really to do with the charger, by the way. .4 volts, it's not that. Yeah, this is pretty screwed, honestly. Do we have PP3v3 sus? Because if we don't have PP3v3 sus, then we won't even be getting close to PM sleep S4L. Oh, we don't even have PP3v3 sus. So we don't, this is not a PM sleep S4L issue. This is a PP3v3 sus issue. Because that has to come before to even power the BIOS to even tell the CPU what to do. So PP3v3 sus is going to be even worse. Because that is like closely tied with the CPU. If we have a short, maybe it'll be a simple short. But it's, who are we kidding? It's not going to be a simple short. Never a simple short. Maybe it is a simple short, but it's never a simple short. There's a short. Are you kidding me? It's going to be an easy little cap. Watch this be an easy little cap. Alright, I'm gonna be brave. No, I better check it. Let's see what's actually shorted. Watch, it's gonna be C6100. This little sucker right there. See if there's a nice big pad I can inject voltage on. There, C7840 is over here. There isn't that much even on this rail. It is probably going to be the switch. You know what? Let's visually inspect the switch and see if it's all messed up. PP3V3 underscore sus switch. I'll be happy. I will be happy if this is the switch. No, come back. Where's our switch? No, we have a switch here. We have to have a switch. U8020 looks like. U8020. U8020. Over here. That honestly looks fine. I don't want to necessarily take that off yet. Alright, so here's a nice place for PP3V3 sus. And it's not a capacitor or anything. One thing I don't like about soldering our wires on capacitors is the fact that sometimes the cap will be shorted and you'll inject voltage onto the cap, and then the cap will be the exact short. So you'll get confused because it's going to get hot anyway if you're injecting voltage on something that's shorted. So it'll throw you off. So we're going to inject voltage and we're going to see what gets hot here. And the sad thing is, even if I fix this, I can't go home yet. I still have to inspect several machines. And maybe fix several machines. Because, one, I need money. 4 amps. Switch to FLIR. It's just coming from this area. Maybe it is a switch. Let's see. Switch. Alright, it's at 1.3 volts. Let's take it up. 2.3 volts. 5 amps. It's under the heatsink. The heatsink is getting hot. Oh no. The heatsink is getting hot. Let's take the heatsink off. This is hilarious. Heatsink is getting hot. It's always the CPU. It's always the CPU. I don't know whether to laugh or to cry, or a combination of both. Oh, are you kidding me? Are you kidding me? Why didn't I look? Why didn't I look under here first? Seriously, why didn't I look under here first? It literally exploded. Anel, you got your wish. You got your wish, buddy. You got your wish, buddy. Good job, Anel. Are you still here? Let's message you. Let's send you a message. Can never win. Every time Anel joins the darn chat, stuff like this happens. The CPU is visibly exploded. I have not seen that yet, John. It's always a tantalum cap for me. Look where this arced. See where it arced? Look at that. That like visibly arced and went on fire. This thing screwed. I want to see the Intel CPU die. If you exploded, at least chip off easily so we can see your insides. Look at this. The die went on fire. $30 volts. John, you want to see 30 volts? Let's take the SSD out. No, I'm not going to do that. It's going to violently explode and I don't want to be... I don't want to... If I do 30 volts, then I have to buy them a new board. So I'm not going to... I'm not gonna do that. I thought about it. But yeah, rest in peace. That's sad. It's just sad and depressing. Rest in peace. What board is this? I'll quote him for board replacement. 1.6 gigahertz, and I wonder if I can get a board cheap enough for this. That could just continue the original price. It is a 1466. No. Okay, I'm done. Thank you for watching.